Hello, welcome to my space station. I'm sure you've all watched my series on quantum physics. It's a very amazing subject, and I've made a lot of videos about it, going all the way from superposition to logic gates and to how supercomputers work and how quantum computers work. So let's expand on this and give you more insight into this specific topic of superposition. So the way I've explained superposition in my previous videos is that if you have one quantum bit, if you have one qubit, and those two are quantumly entangled, right? Then if you separate them, they're both in a superposition. So they can either be, let's take, in a one state, a zero state, and the other can be in a one state and a zero state. So the thing is, the clarity which I had not given at that moment was how this exact thing worked. The concept that I applied that the concept that I applied back then was the Copenhagen interpretation, right? But there are many other interpretations as to how exactly this superposition takes place and how exactly these two qubits are entangled with each other. So let's dive into this. So the first and the most popular theory is the Copenhagen interpretation. This was given by Max Bohr and the Max Born. So these two scientists tried their best to find a way to explain how two atoms can be tangled with each other, and the explanation that they came up with, the reason it's called Copenhagen interpretation, because they figured this out in the city of Copenhagen in Denmark. So the interpretation basically states that if I have two qubits, right, and if they're entangled, we are not aware of any one of these states. So basically what they said is that as soon as one particle is observed, the universe sort of rolls a dice and decides randomly about which particle is in which state. This is based off of complete randomness and is explained by Max Born's law of probability. What he says is that it's called the Born rule also. What it says is that if you have a wave function of this exact atom, and if at a specific time in the wave function, I square the wave function, basically when the wave function collapses, the value I get, I square it and then take the absolute value to always get a positive number. That will be a probability for that exact position in the wave function to occur. This is just a basic postulate of quantum physics, and this describes what is the probability of each event in a superposition to take place. So the Copenhagen interpretation was basically this, but not everyone agreed with it, and especially the biggest high-profile disagreement came from Einstein himself. He did not like the idea of the universe rolling a dice whenever an object goes into superposition. What he tried to do was the hidden variable theory. What this basically states is that as soon as two particles are created and as soon as they're entangled, the universe already decides that this particle will be, let's say, 1 and this particle will be, let's say, 0. So as soon as one of them is observed, the wave function is not collapsing, it is revealing itself. So if I have two qubits, right, and basically according to Copenhagen interpretation, either of them can be 1 and either of them can be 0. But according to Einstein's hidden variable theory, it is possible. It basically says that one of them is 0, one of them is 1, it is definitely 0, definitely 1. Let's say qubit A is 1, then there is a 100% chance that it is going to give out a 1 when you observe it, but you just don't know what state it is in. Basically, he said that when two bits are separated from each other, they will carry the inverse states of each other, and they're already loaded into it. They do not change, right? So this was his counter to that. He believed that the universe should not be taking guesses and there should not be any chances taking place, and the outcomes are already loaded. You just have to observe them. These theories oppose a lot. Then the third major theory is the many worlds theory, which I think I have mentioned in one of my previous videos, but I'll go back to it again. What it basically states is that as soon as two particles, entangled particles, are created, and as soon as you observe them, there are many different universes. The universe spreads out. There is branches of the universe created in which every outcome happens. So maybe in this universe, let's say qubit A is 1, right? But since it's a superposition, qubit K will also have been a 0. It could have been. It's a probability apparently. So what happens is that another universe is created in which that outcome, in which the qubit A is a 0. So now technically you have all the probabilities satisfied, and that does make sense to some extent. So these are the three main theories. And Copenhagen theory mainly builds off of the many worlds theory. However, the hidden variable theory is completely different and opposes them. So basically, Einstein got to work with many other people onto this, and there was sort of a battle on quantum physics about who is correct. Eventually, as time progressed, Einstein obviously never agreed to the to the Copenhagen interpretation, and there were many scientists who actually did not side with the hidden variable theory because they believed that the entire point of the superposition is that the outcomes are random. If the outcomes are already loaded, then how does that make sense? So eventually, Einstein passed away, and it is said that people say that the Copenhagen interpretation was the winner of this entire competition. And nowadays, the hidden variable theory is regarded as just that, a theory. We in physics, quantum physics, we always accept the Copenhagen interpretation, and so the description of the superposition and quantum entanglement, which I've given in my previous videos, matches that of the Copenhagen interpretation because it is the widely accepted interpretation of this quantum entanglement in real life. So does that mean that the other two are false? Not really. It depends how you look at it. They give you the same result, technically. If, let's say, in the Copenhagen interpretation, the particle also has to some extent decided what it's going to be, right? It is not completely random. In this universe, there is nothing completely random. There is also some level of already being decided that, okay, I have a more chance of going towards 1, I have a more chance of going towards 2 or towards 0. But the hidden variable theory, it just says that, okay, there's no chance at all of me going towards the other side. I'm only going towards this. So it really depends on how you see it, and also the many words theory. If you want to satisfy every single possibility possible, that's a very good explanation. So no one's wrong. It's just how you look at it. So I wouldn't call the other two theories wrong. But since many of the major people in physics have accepted the Copenhagen interpretation, we're going to have to live with that for the rest of our lives. I hope you enjoyed this video and learned a lot about quantum physics, and I hope we see you again next time. Thank you.